Okay, now we're going to try to sketch graphs. And we want kind of accurate graphs. Notice that I didn't do a very good job of cutting this 4x4 rectangle in half so that the red dot would go right where it should. So I'm going to fix that. Okay, I'll go from here to here. I think the halfway point is about here. So that distance should be equal to this distance. Now I've got it a little too far to the right. I'll fudge a little bit, put the red dot about here. And now I can sketch a vertical line, although it's not that vertical, it's a little crooked. Well, make your graph better than I'm making mine. All right, so as I said before, this is the origin. Okay, this red dot stands for the origin. I assume everybody knows what the XY coordinate system is. So that your x-axis would be going along the bottom of this picture, and the y-axis going here. Okay, so we're not going to worry too much about the axis. Let's just construct this graph within this rectangle. Okay, now remember how we divided up, let's say, the 1/x graph. Okay, now the origin wasn't here, it was up here, but that's okay. We still divided by moving from the center of the vertical line through the center of the rectangle, goes over to here, and then we cut this interval in half, then we cut this interval in half. Did the same thing to the left. We're going to do the same thing here. Now we're going to be able to put numbers in these things because we're now on an XY coordinate system. So if this is a 4x4 rectangle, you want to probably stop a minute and think, what's the X coordinate here? What's the X coordinate here? And then think, what's the Y coordinate down here? And what's the Y coordinate up here? So I really recommend you stop and think about that and answer that question yourself. What's the X coordinate here? What's the X coordinate here? And what's the Y coordinate here? And what's the Y coordinate here? Okay, well, anyhow, X coordinate here is -2. X coordinate here is 2. Because the origins for X equals 0, of course. This thing has a width of 4. So you got 2 here and 2 here. If I manage to split this thing correctly in half, then I cut the interval from here to here in half. Of course, halfway between 0 and 1 is, well, everybody knows that's 1. And what's halfway between 0 and 1? That's where 1/2 is. And between 0 and -2, we cut this interval in half. We get -1. We cut the interval from 0 to -1 in half, and we get -1/2. Now, as before, I sketched vertical lines. I sketched vertical lines through the points here and here, through the X values that I've now marked. When I did it originally, I didn't mark any numbers. Okay, then I'm going to do a similar thing for my Y values. Okay, I'm going to cut the interval from here to here in half. Well, let's see. What's the Y value up here? And well, the Y value up here is, let's say, first of all, Y is 0 down here. And Y equals 4 up here, because this is a 4x4 rectangle. It's 4 units from here to here. This is the x-axis. That's where Y equals 0. Okay, so we go from 0 to 4. We cut that interval in half. A little hard for me to do that from my perspective here. Maybe I did a good job. Maybe I didn't. Okay, so here's Y equals 2. Cut this in half. Here's Y equals 1. I cut this interval in half. And I get y equals 1/2. I'm not going to mark that because things are getting a little crowded here. But we understand that this is halfway between here and here. I think I've got it a little bit too high, but when you do it carefully. And here we cut the interval from 0 to 1/2 in half, and we get 1/4. Okay, this is going to be important because now what we're going to do is we're going to make a table for x and y equals x squared. Do you know how to do this? But what x values are we going to use? We're not going to use 0 through 10. We're not going to use -10 through 10. We're just going to use these x values here. Okay, so the x values are -2, -1, -1/2, 0, 1/2, 1, and 2. Very simple. Now we do y equals x squared. Well, if we square -2, we get 4. If we square -1, we get 1. Now, if you think you get -4 when you square -2, it's probably because you're using a calculator. We don't want to use calculators at all. We want to use our heads. We want to use what we understand about arithmetic, because we're not going to understand these graphs or these functions if we rely on a calculator to do everything. Now, when you get into big numbers, you got to square 347. Well, by all means, it's a little over 100,000. But by all means, use the calculator if you need an accurate result. Okay, but if you're squaring -2, you should not use a calculator, and you should understand that you're multiplying -2 times -2, which gives you +4. Okay, and 1/2, you should understand fractions, understand that -1/2 times -1/2 is 1/4, and of course 0 times 0 is 0. Here we get 1/4, here we get 1, and here we get 4. And now we have a table, and we can put the points on our graph. Okay, well, what y values do we need? Notice I didn't mark off any y values. I knew I was going to use all of these x values, so I marked. And notice I didn't cut the interval from 1 to 2 in half. You get 1.5 or 3/2. I could have, but I'm not using that. I don't need that to get the shape of this curve. Okay. Okay, anyhow. I need a line for y equals 4. Well, that line is right here, isn't it? Okay, the line for y equals 4 corresponds to the top of the rectangle. The line for y equals 2, well, I could draw that line, but I don't need it. Okay, because I don't have any y values of 2 here. Okay, I have y value of 1, so I'm going to draw the line here. For y equals 1. And then I need 1/4. And of course, needing 1/4, I anticipated that by cutting the interval from 0 to 1 in half, and then cutting that interval in half to give me first a half, then a 1/4. And now we know that this line here has to be 4 times as close to the bottom of the rectangle as it is to the line for y equals 1. And actually, it's getting a little bit high over here. It's more like 1/3. So, could have made it a little lower, but we'll live with what I've got. Okay. Now, about these points. -2, 4. Using the point here. Let's use blue to mark that point. And while we're at it, we've got the point 2, 4. And we see that this point is a reflection of this point across the y-axis. Okay, and then we have -1, 1. Well, here's -1 and here's 1. And of course, we have the point 1, 1, which is symmetric with this point. If I made that line straight as I should have. And then we have -1/2, 1/4, which should be here. And 1/2, 1/4, which should be here. So we've got these symmetric pairs of points. And then, of course, we have a point here. Okay. Now, these 7 points actually form a function. We'll talk more about that. So those 7 points are themselves a function. The domain of that function is a set of numbers, -2, -1, -1/2, 0, 1/2, 1, 2. The range is set of numbers 4, 1, 1, 4, 0, 1, 4, 1, 4. Domain is a set of x values, range is a set of y values. This so far is a function with 7 points. No points in between. Okay, now, of course, often we want to talk about the points in between. A lot of times we want to square numbers other than -2, -1, -1/2, and so forth. So we go ahead and sketch a smooth curve through these points. Now I'm going to try to keep the chalk visible, and I'm actually going to try my best to make a good graph. And actually, that's one of my better efforts. Not too bad. Okay. Now, most people, when they draw a parabola, they don't flatten out enough in the middle because they don't respect point -1/2, 1/4, and the point 1/2, 1/4. You got to respect that. I want to see that respect. Okay. Be respectful. Anyhow, that's our what I call extended toolkit squaring function. You don't have to remember those words, but you'll see them shortly. I've extended from the 7 points to curve connecting those points. You know, I kind of missed that one. So it's not a great curve, but it's nice and symmetric at least. It's actually pretty good effort. At least I'm proud of it. You do better. I want to be proud of you. Okay, now for the exponential function. Okay, well, I'm going to always start with the same x values because those are the ones that I really need in order to graph function. Okay, now one thing that happens with the toolkit exponential function, remember what I said is we're not going to use a calculator. Okay, we're going to do only calculations that we know how to do. If I use all of these values, a couple of these values that we can't calculate. You don't know how to calculate them. I know how to calculate them, except I can't get an exact answer because you can't write down the exact answer in decimal form. You can't locate the exact value on a graph. We're not going to use those values, although this function is defined for those values. Okay, so we'll see what I'm talking about in a minute. Now let's start with the easy numbers. Okay, 2. What's 2 to the second power? Well, that's 2 squared, that's 4. What's 2 to the first power? Well, that's just 2. What's 2 to the 1/2 power? Okay, write down your calculation for that one. Okay, no calculators, write it down. Well, you don't know. You have no clue. Unless you've had a year of calculus, then you could write down at least the formula for e to the x, and then maybe if you know the calculus pretty well, you write down the formula for doing 2 to the x, but it's an infinitely long calculation that never stops. You never get an exact value. So we're not going to use 1/2. I'll just draw a little wavy line through this. And I'm going to say, well, you'll worry about what I say there. And what I'm going to say, this exists, but we can't calculate it. Okay. Maybe ECC exists, can't calculate, but we're just going to use a wavy line. Okay. Here we're going to use a wavy, well, we'll see that in a minute. Okay. What's 2 to the -2? You should know. Okay, but maybe you haven't done any calculations by hand in the last few years. Maybe you're really rusty. Maybe you never knew, but I think you did at one point. Okay. What's 2 to the -2? It's one over 2 squared. Negative exponent means you do reciprocal with the absolute value of that exponent. That's 1/4. Okay. Now, if x is -1, think of that. What do you think? What I just said, what do you think you're going to get for -1? Well, it's 1 over 2 to the 1. Next 1/2. Okay. Now, what about negative 1/2? Well, that would be 1 over 2 to the 1/2. You don't know how to calculate 2 to the 1/2, and nobody can calculate it exactly. Not your calculator, nobody, not possible. Okay. It exists, but you can't calculate it. You can estimate it. So anyhow, we're not going to use this one. And what's 2 to the 0? If you say 0, I want you to stop and think. Okay, 2 to the 0 is not 0. Okay. Any number to the 0 power is 1. So don't make the mistake of thinking that this is 0. It's going to screw up your graph, going to screw up your thinking about the function, going to screw up your whole life. Well, probably not that bad. Okay, but still, think precisely. Learn to think precisely. You're less likely to screw up your life. Okay. So what I'm going to do now is I'm going to draw my 4x4 rectangle, and I'm going to do this off camera because no point in you watching me do something you've watched me do 3 or 4 times. Stop and do it yourself. Okay, little cockeyed, but here's my 4x4 graph. And it's implicitly 4x4 with the origin here. So we know the x-axis is here and the y-axis is here. Okay, so we could say, okay, here's my x-axis, here's my y-axis. And here's 2 on the x-axis, and here's I'll draw an extended dotted line here and label it. The y was 4 line. Okay. Now, what's this line? What's this line? What's this line and what's this line? Okay. Well, you should be able to answer. This line is, think about it. Don't, pause and have to think about it, but this is y equals 2. This is y equals 1. And that's kind of swap here. Try to write that one clearly. Okay, now here is y equals 1/2 line. And here I'm going to have to label it a little bit low, y equals 1/4. That would be this lowest line. Now, each of these lines is twice as close to the bottom as the one above it. So the y equals 4 lines here, the y equals 2 line is twice as close to the x-axis to the bottom of the bottom edge of the square. Y equals 1 is twice as close to the bottom edge as y equals 2, and then twice as close as y equals 1 gets y equals 1/2, and twice as close gets to y equals 1/4. Okay, those are important characteristics. You should understand that. All right, now we can label these numbers. Okay, if x is -2, y is 1/4. So here's the 1/4 mark, and here's -2, of course. I guess write that in. And you know what I did? I did something that's unnecessary. I did the x equals 1/2 line here. Okay, that was totally unnecessary because we don't use x equals 1/2. Still, I'll keep it in there because it'll allow us to make an estimate of what this 1/2 pound of 2 is. Okay. Okay, so -2, 1/4. Yeah, that's this point. -1, 1/2. Yeah. 0, 1. There it is. 1, 2. There it is. And 2, 4. There it is. There's our graph. Okay, that's a 5-point graph. That's what I call our basic toolkit exponential function. Okay, consists of these 5 points. You can extend that by sketching the curve from here to here. And now the function is defined from -2 to 2. Its range goes from 1/4 up to 4. If the domain is from -2 to 2, the range is from 1/4 to 4. Now, if you extend this to all positive x values and all negative x values, your range keeps, the lower part of your range keeps shrinking down towards 0, never reaches 0. And your upper end of the range is unbounded, it's unlimited, so it approaches infinity. Just kind of swirl that away. Okay, so anyhow, right there is your graph for your toolkit exponential function. The anomalies here, it's not an anomaly. If you don't know the 2 to the 0 is 1, you're going to end up with a point here. Instead of having this nice smooth exponential curve, you're going to have a curve that here, it wobbles down here and comes up here. It's going to be terrible. It'll ruin your investments for life, because this is kind of a graph that indicates how an investment at constant interest rate will grow. You use different numbers for the x and y axes, depending on your investment and how fast it grows. But the graph is going to look just like this. Okay, so in your financial future, important. Okay, more about that later. Okay, now for your toolkit reciprocal function, again, we're going to start with -2, -1, -1/2, 0, 1/2, 1, 2. And we're going to do the reciprocals. And well, 1/2, -2 is, I'll write it up, 1/2 is -1/2. 1/-1, well, actually it's -1. 1/-1/2, this 1 times -2/1. You want division is by fractions and multiplication by the reciprocal. So we get -2. 1/0. You should know that division by 0 is forbidden. We'll talk more about the reasons why. It's because you can count. Well, let's do the rest of these, and then I'll say a little bit about that. 1 divided by 1/2 is 1 times 2/1, which is 2. 1 divided by 1 is 1. 1 divided by 2 is 1/2. Okay. Now, why is 1 divided by 1/2 equal to 2? Because you can count to 1 by 1/2. 1/2, 1. Okay. Half of something and another half of something, you got 1, right? You can count to 1 by 1/2. You can't count to 1 by zeros. If you're counting by zeros, you never get anywhere. So division by 0 is undefined. You could say it's infinity, but infinity isn't a number. You can't plot it on a graph. It's not a number. And yeah, different infinities have different sizes. There are all kinds of reasons you don't want to say that. Anyhow, we're going to not just use the wavy line through this. I'm going to cross that sucker out. Okay, we're not using 0 as part of the domain. So the domain has been changed. Okay. In such a way that it can't include 0. Okay, now I'm going to go ahead and resketch this picture and make sense of it. So I'm going to pause the video. So next video, you see that picture will magically be there. Okay, we see that as before. Here's your origin. So your x-axis would be here and your y-axis would be here. I've taken the interval from the y-axis from x equals 0 onto 2, cut it in half, cut that interval in half. Here, I've taken this interval, cut it in half, cut that in half. I've done similarly on the other side of the on the y-axis. Take the interval from 0 up to here, and this is 0. Now y is 0 here. I take this interval, cut it in half, I get this, cut that in half, I get this. This interval cut in half, cut in half. Again, I stress this idea of cutting these intervals in half. It gives you a much better picture. It gives you a much more accurate graph. Okay, now I've drawn my vertical dotted lines, just as I did on this picture. And I've labeled them. This vertical line is the x equals -1 line because at every point on this line, x is -1. This is the x equals -1/2 line. Every point in this graph has x coordinate -1/2, or every point on this dotted line here through the x equals -1/2. Okay, and then the x equals 1/2 and x equals 1 lines. Not drawn particularly well. You know, my spacing here is getting a little bit weird, but it'll work out. All right. And of course, on this line, you can say x equals 2. And on this line, you can say x equals -2. Okay. Now I've got horizontal lines. Okay. If it's not obvious to you, stop and think, what should the y values be here? Y equals what on this line? Y equals what on this line? Y equals what on this line? Each of these lines. Okay. Actually, I kind of accidentally wrote down what y equals on this line. It turns out to be right. But up here, y is 2. Down here, y is -2 because the origin is in the middle of this square. And we got to go into negative numbers to get down here and positive numbers to get up here. Same as we did on the x-axis. Unlike what we had to do here, we didn't have any negative values, any negative y values on these tables. Okay, now we plot points, and the points are very simple. -2, -1/2. We find -2, and we find the, let's go ahead and label these. This was the y equals 1 line. Hopefully you thought this through. This is y equals 1/2. Y equals -1/2, y equals -1, y equals -2. This point will lie at the intersection of the x equals -2 line and the y equals 1/2 line, -1/2. Okay. And that's going to be here. X equals -1, y is going to be -1. There's the x equals -1 line, y equals -1 line. Here we are. And the -1/2, -2. X equals -1/2 line, y equals -2 line is here. And as before, we connect these points. In this quadrant, we get this point, and this point, and we connect them. We get a nice smooth curve, and that's it. Okay, within this 4x4 rectangle. Of course, the graph could be extended beyond the 4x4 rectangle, but for the toolkit functions, you kind of stick with the 4x4 rectangle, at least when we're starting out. Okay. Now, one thing you don't do is you don't try to connect this point to this point. Why don't you connect? Because there is no value for x equals 0. X equals 0, of course, is this line here. So if we connect this point to this point, we're going to go across this line somewhere. And once we go across, we said that that's what 1/0 is. That y coordinate would be 1/0, but 1/0 can't be defined. Okay, so if anybody does that, I'm going to make you count to 1 by zeros. Okay, I'll stop you after a day or two. I'm kind-hearted like that. All right, so here's our graph of the basic reciprocal function. So this is y equals 1/x function. This is the y equals 2 to the x function. This is the y equals x squared function. And they look a whole lot like they did when I did this without telling you any coordinates. Okay. However, now you know how the coordinates are calculated. And hopefully, just to emphasize, you know, the coordinates are not calculated with a calculator. Okay. And graphs are not constructed in this course with a graphing calculator. Now, sometimes you'll make one, just maybe check yourself and see if you did the right thing. But we construct graphs by moving these squares around. Okay, now we're going to talk about that next.